Hello, guys. Thank you for coming to see me. I wasn't expecting too many people. What Eric said is not totally true. This is the first time I talk, so forgive all my mistakes. So, how many of you have heard about architecture components? Raise your hands. How many of you actually use architecture components? Only one person. This should be three. We're getting better. So by the end of this talk, hopefully you'll always have reasons to use, specifically talking about life cycles, because if you're not using them, I probably think you're spending a lot of time fixing bugs related to life cycles. So as Eric was talking, thanks for the introduction. I'm Dario Mungoi. I just moved to Canada to join Shopify, the mobile Shopify team back in Ottawa, and also an Android GD. So part of being an Android GD is to give talks, not less talks. That's why I was saying, like, I don't do too much talks, but I tend to write blog posts. Primarily, I used to write in Portuguese. That's my native language. But I also have some English posts in Kotlin, mostly like really basic stuff most of the time. So the first thing is, what are the new Android architecture components? That's probably the question for those who don't know about what are architecture components. So basically, so how many of you are starting to develop Android apps or are starting like beginner Android apps? Yeah. How many of you have been developing Android for less than a year? More than a year? Less than 2 years? Okay, cool. So basically, as an Android developer, like the big problem that I think most of you have faced, I faced them myself. It's like when I was starting, I'll go to the documentation website, and at the time I didn't know really how to read well English because I'm a native Portuguese speaker. So I'd go there and like see all this activity stuff and had no clue where to start. I knew there was an activity, there was an intent, there was a fragment, but like how all those things came together was like such a mystery, and I have to take a lot of time. And I think that resonates with a lot of things here. And like over the years, we have been seeing like a lot of discussions, like really heated discussions between teams around what is the best way to build an Android app, what is the best architecture to use. So if your team never had some time discussing all this stuff, something is definitely wrong. So Google decided to come in and give their opinion on this. So it doesn't mean that the architecture components are like the definitive way to build Android apps or to architect Android apps, but it's just Google engineers' own opinions. And they're pretty much a set of independent components and are components that are very they're independent. You can pretty much use each one of them. I'm going to go through each one of them shortly, but they're also meant to work together. So like they're very powerful when they work together. And as Eric was talking about moving fast, this library in particular, like have been moving to a new version every week. So last week, I think for the last week, we had the beta 1, but before that, I had to change this presentation 3 times to update the version because it was alpha 7, 8, 9, and it was a mess. So basically, the Android architecture components have 4 different components. So the first one is room. So for those of you who have tried to write to persist data on storage, and I mean persist real data, like very structured data, you probably know the pain around dealing with SQLite or writing content providers. I've done it myself, and I don't want to do it ever in my life again. So Room pretty much comes in as a object relational mapper that will help you to create these databases. And the only thing you have to worry is to like make sure you know a little bit of SQL, and then Room will auto-generate everything for you. But Room is not the scope of this talk, but at the end I'll provide some resources where you can pretty much see more about Room. And then going into the next 3 components are pretty much the focus of this presentation. So the first one is LiveData, and pretty much LiveData is a data observable component that respects lifecycle. So I wouldn't go into too much detail right now because I will be repetitive when I talk about, because these 3 Remaining components, I'll talk about them like independently. So I'll just go briefly. So basically, LiveData allows you to observe data and make sure you do this data observing, like respecting the life cycle. And then we have ViewModel, which solves a problem that you can encounter by using only LiveData. It's also a secret, so please don't leave the presentation right now. And then you have Lifecycles. So pretty much the Lifecycles, just a set of classes that are going to help you to build lifecycle-aware components. So to get started with Android architecture components, at I/O earlier this year, Google announced their own repository. So at the top level, build.gradle file of your project, you should just have to, in the repositories, add Google. This shouldn't be very hard. And then after that, you just have to add the dependencies. As again, this is one of the parts that's changed a lot in the slide because I always have to keep in track with the current version. So now we're in beta 1, and which means you can safely start using in production. Even before you could use it in production, but you know, we always want to have something that's at least beta because it's Google that can back up at some time, and after having an application in production can be a big problem. Then you define the dependencies and you should be ready to go. So to start talking about Android architecture components, how many of you know about the ModelViewModel pattern? Okay, pretty much everyone, so forgive me if I say something wrong. So basically MVVM stands for ModelViewModel, and basically it means we're dividing our application in 3 different parts. So you have the view, which is pretty much in Android, it's pretty much responsible for like rendering stuff and all operations that are related to the UI, such as displaying data. And normally the views are our fragments and our activities, and of course you have custom views. And then you have the ViewModel, which is responsible for providing like a stream of data to the views. The ViewModel is agnostic to the view that's listening. Any view can actually subscribe to this ViewModel and receive the data that it's passing it, ready to be displayed in the UI. And then we have the model, which is so I like the repository pattern, but any other team, like this is the part where the team decides exactly what you want to do. So the repository pattern means that you have this interface that's going to be the repository that you can then pass it different implementations depending on what you want to do. So normally you want to have the repository fetching the data from the network and saving it to the storage, and then like returning the data back to the ViewModel, and then the ViewModel like return the data back to the view. So the MVVM using the architecture components. So in the view side, we'll have, as I said, mostly like we consider the views to be the fragments, and the activities we have like a lifecycle aware component. So this is pretty much for you to see where the architecture components, where each one of the components fit in the model, the MVVM, which was pretty much the pattern that Google decided to go with for the implementation of this library. And you have the ViewModel, which interestingly also remains with the name ViewModel. And then in the model itself, the only thing that was added from the architecture component is room for the database. So you pretty much have room handling all the database creation for you, as I explained earlier before. So before coming to Shopify, I had a startup back home. It is still running. So it's an app that shows movie times, and you can purchase tickets for movies and events. And like I'll be pretty much using that app as an example so that we can follow how we could use Android architecture components, how we could use Android architecture components to achieve a lot of the tasks that we had there. So basically in the app, we had this screen that would show us all coming soon movies. So pretty much like all coming soon movies was just making a query to the server that would say, please bring back all the movies that release date is greater than today. So it means the movie is not released yet. So at the time, all this data was stored in the server. But of course, because I come from a country and a continent that data is not like data is very flaky, like persisting data is one of the best things you could do. And like the first thing that I would think, so I didn't do that before leaving to Shopify because of what I just said. Like I didn't want to write any SQL before that. But now with Room, like I had these ideas and kind of like keep that project running like as an experiment. And using Room, this is the syntax. So I'm not going into details. We can take questions later about Room, but I'm not going into details about Room because it's not the scope of this project. But basically, if you had a Room and we have, assuming that we all know about Room and we created this database and we want to query for the coming soon movies, would have like 2 lines like this. So the first, on the top, we have to define the query, like it's a regular SQL query. And then would have to define like the method, which is a method that returns a list with movies and takes as the argument the date. So pretty much this method is defined as an interface. I said I wouldn't go into Room, but I feel like explaining a little bit. So like this would be defined in an interface, and this is how easy Room is. So you just define the interface on how you want to insert the data or query it, and Room is going to generate all the boilerplate code for you. So the only thing you have to know about SQLite is actually to make the queries. So by making this query, we would have the list of our coming soon movies, and it will be ready to present to the users. But then there are few problems with how this query is built. So assuming that I have this repository pattern where it goes to the network silently, fetches the data, stores in the database, and pretty much all the data that's showed in a UI comes from the database. If the data changes, our list, our recycle view will never get the latest movies because it's just a list. So there is no way to actually like kind of update that. So that's the first problem with using the query like this. And the second thing is, for some reason, you might want to, so this example of movies is not very applicable, but for some reason, you might want to listen for that same data, for the same data on that table in multiple locations. Let's say you have an app that have, I can't think of an example right now, but you want to like get to listen that data for multiple locations. So you wouldn't be able to do that with this list. So to do that, Android architecture components introduced a component called LiveData, which is just an observable data holder, and that's lifecycle aware. How many of you know about RxJava? How many of you understand RxJava? How many of you use RxJava? Okay, it's fair. Like, it's one of those things that when you think you're almost understanding it, and then you realize it's just a noob. So, so basically, the whole concept of RxJava is like to think of data as a streams. I won't go into that because it might be a new presentation of its own. But basically, LiveData allows us to wrap that return type of that query, and it means that we will be able to observe for changes. So basically, if we wrap this is the same query, the same method, but instead of returning just the list, we can return the live data. And after returning the live data, we could use this query like this. So we have the movies repository, and that get movies returns live data. And because live data is observable, we can just say observe, pass this. So basically, this is the scope or the life cycle that it's tied to it, which you're going to go into details. And then you just implement the onChange method. So by doing this way, like wrapping the response around the live data, it means we can pretty much create any live data in different locations whenever that data in the database related to coming soon movies changes. Everywhere that's listening is going to change too. So the beauty about live data is that it is lifecycle aware. So that this variable, this parameter that I was talking about, is actually Lifecycle Owner, which I'm going to go into details a little bit in a little bit. But basically, it allows the live data to know that if by any chance I don't have this life cycle, all the data is not going to be emitted. So basically, as I was saying, one of the problems that pretty much I want to bet that everyone in this room have faced is loading data and then leaving the app. When the data comes back, you have this illegal argument exception. If you never had this is a terrible sign. Because like it's such a trivial thing. It's very hard to, like Android lifecycle is one of those things that's very hard to understand most of the time. So basically LiveData, because it knows about a lifecycle, it's going to make sure that if you observe data and then the lifecycle where it's tied to no longer exists, even if it's called, it's no longer going to be invoked. But then there's one problem arises by using only the live data is configuration changes. So the first thing is that we needed to know about the life cycle. Now we're safe from the life cycle, but there's another danger in this, which is configuration changes in Android, which also deal with life cycle. So you might be doing this network call and then you rotate the device and everything goes wrong, and we end up doing this trick on manifest of allowing only portrait mode. If you never done that, also it's complicated. So to kind of handle this, the next component in the Android architecture components is the ViewModel. So basically, the ViewModel, it's the ViewModel also. It's the same as the ViewModel from the ModelViewModel architecture, as we talked before. It's a simple class designed to store and manage UI-related data, and it survives configuration changes, and it does not introduce memory leaks or whatsoever. No reference to activities, any fragments, or views. So basically, how does this go? So if you take a regular process on how Android activity lifecycle might go. So when the activity is created, you have the OnCreate method, and then you have an onStart, and then you have an onResume. But at some point, so at onResume, the activity, the UI is already visible to the user, and at that moment, the user changed the configuration, let's say does a rotation. So pretty much that activity is going to be destroyed, and then it's going to be recreated, and then at the end of the thing that we're doing, we leave, and that the activity is going to be destroyed. So basically, the view model is going to stay alive until all that scope. And basically, only when that activity or fragment is killed. So basically, the view model is tied to a specific scope. And normally, if you pass in, like you're getting a view model from, let's say, on a scope of a fragment, it's actually going to get the scope of the activity. And as long as that activity stays alive, the view model is going to stay alive. So unless the activity is done or the process is killed, the view model is going to remain there. So this allows, because of this, it means because we have this view model as long as our activity is there, it means we can share data between view models. So let's say between UI components. So let's say we're in two-pane tablet layout. We have the same activity, two different fragments. We could use the view models to send data back and forth from one fragment to another. VMs are not persisted, as I was saying, if the application is killed by the OS. So you have to be careful about what kind of stuff you store there, because Android is not very reliable sometimes, and if by any chance your app process is killed, your view model is going to be gone too, so you have to make sure you don't store a lot of things there. And because it's kept in the system for a while, you also have to make sure you don't put everything. It's like, okay, don't go after the presentation. Say, view model survives across configuration changes. Let me put everything there. That's not going to work. Well, it's going to work, but it's definitely not a good practice. So some typical use cases is that you might ask, okay, but we already have the saved instance state. But as you know, the saved instance state pretty much takes a bundle, and there are some limitations with the bundle. So a good use case to have the view model, let's say if you have movies, if you have movie details screen, and we have the movie ID. So we would load the data, and then we save the movie ID on the saved instance state, and then whenever we rotate the device, we come back, we get the view model, and then we load. So this would mean that we're only storing the ID into the saved instance state, and then we pass in that ID into the view model so that we can load the data into it, and then we'll be good to go. So this is how you would create a view model. So it's simple as extending a class, extending the ViewModel class. So pretty much the ViewModel class is an abstract class that has one method, if I'm not mistaken. I think I checked this morning. That's onClear, which is the method that it's called when the system is removing everything else. So pretty much inside the ViewModel, we remember that LiveData that we had in the repository. So pretty much we take that LiveData, we put it in the ViewModel, and when in the constructor, when we're starting this ViewModel, we just get the movie repository, load the movies, or load the information that we want to do to the LiveData, and then the activity, or the view in this case, only needs to get the LiveData from the movies. So this will make sure that if you load some information, it's going to be persisted across configuration changes, because the ViewModel is going to stay alive during that period. So to get the ViewModel, there's also this class. That's pretty much a utility class called ViewModel Providers. And the ViewModel Providers takes the Lifecycle Owner as well, which is going to discuss in details a little bit more. And you pass in the name. So basically what this is going to do, below the ViewModel Providers, there's a ViewModel Provider class. And below the ViewModel Provider class, at the very end, these view models are actually stored in a hash map. I really recommend you guys to go and take a look at the support framework. Source code is very simple, like how these things are done. I actually did it myself this morning, so definitely recommend. So say this, now that our live data is inside of ViewModel, the only thing we have to do to observe the data. So we just get the ViewModel from the ViewModels provider. So by the way, as long as you have a Lifecycle Owner, which means a fragment or an activity, you can pretty much get this use this ViewModel provider to get your ViewModel from anywhere in your application. So it doesn't really say that you can actually get the same ViewModel from two different parts. So if you want to use as the example of two fragments that I was saying, you can have get the ViewModel in one fragment, get the ViewModel in another fragment. It should be perfectly fine. I just can't think of a really good use case to do that right now. So throughout all the presentation, pretty much we've seen like there was this that I never showed what it was just this, and was probably very hard to understand. And basically, the this stands for the lifecycle, or the lifecycle aware components. So basically, the lifecycle aware components are interfaces that let you build lifecycle aware components. So it's pretty much, I think the lifecycle is just an interface. Is that it? One of those, I forgot the names, but that's pretty much just an interface that has the method getLifecycle, and automatically adjust the behavior according to the current lifecycle, as we're going to see how you could build your own lifecycle aware components, and helps avoid memory leaks and all these kind of problems that we had with lifecycles before, like loading data, leaving, and coming back, because now we know now with these components, we can know exactly what is the state of our application. So to kind of really understand the life cycles, there are two different concepts to understand here. So the first concept is of states, and the second concept is of events. So pretty much everything that you're seeing right now are states. So you have the initialized state, and then when the activity started, you call the OnCreate event. So the OnCreate is actually an event that takes to the created state. So after that, from the created state, we have the onStart, which we have the onStart event that actually leads us to the started state. And then going the same path, we have the onResume, and going the same way back, we have onPause, onStop, and onDestroy. So this is very important to understand because the lifecycle, these classes that were introduced in the lifecycle, this class that were introduced in architecture components allow us to hook into these two types. Either you want it to hook up into the events, or you might want to hook up into the states. And this will look something like this. So going back to our movie example, and if we are in a movie detail screen and we have a trailer, and for those who also try to build like a movie player or something like that, probably know that it's really, really big pain to handle, like when you're going to start the playback, when you're going to stop, if the user opens WhatsApp while they're doing, you have to stop the playback and all this kind of things. So there's a lot of wrestling. There used to be, no, there's not, there used to be a lot of wrestling with lifecycle stuff. So basically what would happen, let's say on your own start, you'd like get the video player, do all the configuration, and initialize everything that you need to put to start playing the video, and then on resume you might do anything else, and then on stop. But then this is one thing, but if we have, like, let's say for some reason we want to see everyone else that's watching the same trailer in our region, and then we decide to add a location provider, it means that all these lifecycle methods are going to be like 10 line longs, and I'm pretty sure like most of you have encountered this case where you have like on start with a lot of things doing, and then you have to undo the same stuff on stop. So this is terrible because you end up like with these events, like your activity with a lot of code, and it's kind of very hard to manage. And chances are you're always going to get this wrong because you never know when the activity is, like the on start method is going to get started or something like that. So the new way, as I was saying, going back, I have two concepts. The first concept is the events. The second concept is the states. So basically, you can create a lifecycle aware component by implementing the lifecycle observer interface. And then there are annotations such as on lifecycle event. So basically, on lifecycle event, you annotate any method in that class. So on start was just for readability, and somewhere else in the team comes and see that, okay, this is an on-start method, but it could be anything else. So it's just a regular function, and then you annotate with the on-lifecycle event, and then you define the lifecycle that you want. So in this case, we would take all the logic that was in our activity and we'll put it like for the video player, and we'll create this component that only knows how to deal with the video player stuff. And then we'll take the same approach and create a component that only knows how to deal with location stuff. So in this way, by saying we want to hook up to the on-lifecycle event on start, it means that block of code is going to be executed as soon as the lifecycle, which this component is tied to, like triggers that event. So the second option would be, let's say you only want to do something after you know that this state was concluded. So let's say you want to make sure that you only start playing back the video after like the whole UI is configured or something like that. So you want to make sure you can use, inside the lifecycle observer interface, you can like just say lifecycle get state, and you do is at least started. In this case, started is state. So we want to make sure, we want to execute something only if the state is reached. So this is actually in a case, so this method, this function is not going to be called right away, but it's actually safe because whatever you're calling enable the code inside that if statement is only going to be executed if you're already in that state. So if you're not in that state, nothing is going to happen, which means you're safe until you get to that state. You're not going to have any crashes or something like that. So basically, to do this, to add this component, so you already created the components and you want to add them to your activity or your fragment, the only thing you have to do is to get lifecycle and add observer, and you pass in a new instance of that component. So basically, as I was saying, like there's this concept of Lifecycle Owner, which before the library reached beta 1, there was this class called Lifecycle Activity. And again, if you go and look at the source code, you're going to be like, why Google didn't do this before? It's so simple. Like it's pretty much the same. It's pretty much an activity that's implement this lifecycle interface that has this method get lifecycle. So this is what I was talking about. So the lifecycle owner is pretty much an interface with a method to define that component has a lifecycle. So before, this is another part I had to update for my presentation. Lifecycle activity and lifecycle fragment were the components that came out with the library from day 1. But then, as announced on during I/O, like there was always this intention of making sure that this would come straight into activity and fragments. So now you no longer have to extend lifecycle activity or extend lifecycle fragment. You can directly use the activity and fragment, and you're going to have this get lifecycle method that you can add observers and your own lifecycle components. Just make sure you update to the latest support library so that you can benefit from this. So basically, this is an example of a lifecycle owner, as I was saying. Before, you have to do lifecycle activity. Now it's just the app compact activity and the fragment from the support library, and you're going to get this get lifecycle, and then you add an observer, which is the component. So now your OnCreate method, the only thing you have to specify is like adding all of those components. So if you want to add a video player, you want to add location and all this kind of things, whatever you want, you just create a component separately, and then you add it there, and it's going to make your code much more readable, safe, and also it makes sure like you know exactly, you pretty much do a really good separation of concerns that have to bloat your activity with all unnecessary code. So basically, we're done. And like as a summary, I want you to take away that architecture components are pretty much an addition to what we already have in the framework. The architecture components work with Kotlin. How many of you develop for Kotlin? Start writing code? Okay, so pretty much you can still do these things in Kotlin. If you find a bug, please like just right away try to report, but it should be working pretty fine for all the regular use cases. So it helps us solve complex problems. So before, as I was saying, was a really big problem. I personally suffered a lot with the wall screen rotation. I remember doing the Udacity course a couple of years ago, and like my reviewer spent like a week fighting with me because of all this persisting data across screen rotation, and I kind of hated him for that. But if this was the time, that would be probably take like a day, no, not even a day, a couple of minutes actually. So it helps mitigation of memory leaks and all those exceptions that we have, and it simplifies code. So more than writing too many features, like it's very, I find pleasure at least in reading very well-written code where things are very separated, and make sure like you can pretty much work in parallel because each components are like decoupled from everything else. So with this, I get to the end of my presentation. So as a resource, there's the developer.android.com that I learned. It's called DAC /architecture/arc for like the short version, but it's pretty much the place where you can find all the resources about Android architecture components. And if you go to the first page and you scroll to the bottom, you're going to find a whole bunch of articles written by the engineers that work on this, such as Yit Boyer and Florina Muntenesco, like all the recent talks that I did at GDD Europe a couple of weeks back. And hopefully, I think like there's more stuff coming in from DroidCon. And you can get more details about the other architecture components, such as the room and so on. So thank you. So I think we have time for questions, right? Please fire them up. Sure.
What's your opinion on how LiveData, since it can report like data changes, how does that fit in with RxJava if you do that similar pattern to observe data changes?
Cool.
Both them together?
Yeah, I omitted that because I wanted to have at least one question. So I'm joking. Basically, Live Data also has method. I'm not sure about the name, but I think it's to observable. I think now it supports observable, flowable, and single, if I'm not mistaken. Mustafa, can you confirm? Yeah. Okay. Yeah, you can pretty much, if you're using live data, you can just use to observable, to flowable, to single, and then you can still work with your RxJava constructs and functions. Yeah. Any other question?
So, you see a lifecycle owner component. It's like a router class, right?
Sorry?
So you had a video player.
Yeah.
Right? So, is it like a decorator pattern for the video player?
Yep. So basically, as I was saying, you would normally have in your activity, you pretty much everything that was related to lifecycle, you would have to hook up into your activity or your fragment. So you have like the OnCreate, OnStart, OnResume, OnPause. So let's say for the video example, you'd say OnCreate, you'd create the instance of the YouTube player or Exo player, whichever the library that you're using. And then let's say on start, you'll configure. I personally never done like a lot of video stuff. I normally delegate it to open to YouTube. That's the beauty of intents. But like I'm assuming that you probably have to like do all kind of initialization, and then on resume, which you already know that the UI is visible, you want to start doing the playback. So you would have all this code, and if you have only one component in that screen, it's perfectly fine. But then the problem is when you start having too many components that rely on this, you start having this OnCreate or like this lifecycle event methods being very full of code that at some point becomes really hard to understand. So basically, by creating a lifecycle aware component, it means you can start like take all that logic, like create smaller components for each one of the things that you're trying to build. So in this case, for the video player, you create a class that extends a lifecycle observer. So it means that class knows about the lifecycle that it's tied to, like the scope that it's tied to. So it means when the activity, when you're creating, let's say, so your activity start, you get a life cycle, you add an observer, and you add that component, right? So basically, that component already knows about the scope of this specific activity, in this case, the trailer activity. So the moment that the trailer activity is going to call the OnCreate event, if you're using, depending on the type of depending on the way you want to hook up to this event, if you're using like this annotation, it means by the time that activity reaches the onStart, calls the onStart event, this method is going to be triggered. It's pretty much the same way that would happen in that specific line. So it means you have all the code for your video related stuff in one place, and your activity only has to know about like observing this different components. Yeah. Sure. Thanks. Yeah, sure.
So is a lifecycle activity a lifecycle aware activity?
So before that, so lifecycle activity they create was pretty much, I can't confirm because I can't remember. I slept on the train after reading that because it was boring. But it's pretty much like the lifecycle activity extended fragment activity, if I'm not mistaken, and then implemented the lifecycle class, which is just an interface that has the method get lifecycle. So as I was saying, you shouldn't worry about this, because if you're using support library, if you're not, that's a bad sign as well, because nowadays not using support library is kind of complicated. So now just make sure you update your support library version, and you make sure so you update your support library version and you make sure you have, you're going to have that get lifecycle by default because it was released with the new version of architecture components and the new version of support library. Yep, cool.
Did you have any experience with other kind of like more mature MVP and VM like third-party libraries before you looked into Android architecture? And if you did, like, do you have any kind of like anecdotes about how they compare to the like official Google way?
So like, I'm glad you just said that. It's like official Google way. I kind of, I don't.
Like, you know, people hate like still maybe hate fragments, right?
That's a whole talk about fragments. That's okay.
For example, like Mosby, if you're familiar with Mosby.
I don't think I'm familiar with that. So actually, it's kind of interesting. Personally, I never used a lot of like architecture that I like. It's MVP, and I always did that myself. Never used any library because I think it's like pretty easy. So I wouldn't even use Dagger because all the cases that I had like were so simple that I didn't have to use Dagger, for example. So like it's actually a very, we can pretty much stay the whole night discussing this because someone else is going to come up and say that MVI is the best for some reason. So I would say that these architecture components are good because they're very solid. Like MVVM is something that's been used and been tested by the community, and like this is a very solid pattern, and I would advise anyone starting a new project to start with that. But if you already have your own project, and let's say you want to only add the room databases, like you don't have to worry because as I said in the beginning, they're all independent components that you can hook up in different part of the apps. But of course, they become really powerful when they're working together. So you're really free to choose, let's say, you're not necessarily using room, but you want to use ViewModels because of the configuration changes. You could use that, or you could use LiveData, or as he asked, like, you're using RxJava, but you also want to use LiveData, so it have this possibility of like converting like your LiveData to an observable, flowable, or anything like that. So I wouldn't say like there is a better architecture. This is just Google opinion, and I personally feel that it's strong and it makes a lot of things easier. But you always feel free. You always feel free to grab whatever you want and whatever works for you and your team, which is the most important thing. You have to pick stuff that works for your team. There are teams that all these architecture components might not work because they have built like their own mechanism, their own view models or something like that. So it's really up to you and your team whether you think it's good or not. So it's just about experimenting and seeing if it works for you guys. Yeah. One more question. There was one more question. Okay.
Talk a little bit about how these on-lifecycle event callbacks get wired up. Like you have to register them at some point, or it's just the app. You have to specifically, yeah. Talk a bit about that.
Okay, so basically, so you have this interface called Lifecycle, and then only has one method called get Lifecycle. So basically, all lifecycle owners, which are fragments and activities, implement this interface so that you can get the lifecycle from those methods. And then after you get the components, you get the lifecycle. So in this case, so you get the lifecycle, and then you add the observer, and then you pass in a new instance of the component that you have written all the methods to hook up to the lifecycle. So as simple as that, and it will take care of you. You shouldn't be worrying about what's going under the hood. If you want to, and I guess I go back and recommend, like it's very simple.
Yeah. Is that interface like, so that has like all the possible lifecycle combinations, like find that interface, or?
So it doesn't do lifecycle combination. So as I was explaining back here, you have two ways of doing this. So one way is to kind of having methods triggered when a specific event is called. So we have different events such as onCreate, onStart, on pause, on destroy, or on stop, or something like that. And then you can call these methods. Yeah, you can annotate using this annotation to say that whenever that event is called, I want to execute this code. But for example, let's say you don't necessarily want to be listening for a change but when an event is executed, but you want to make sure that a specific path of code is only reachable after you are sure that you already have that specific state. So in this case, you use the states enum. So you pretty much do lifecycle get state, and you check if it's at least that specific state that you're looking for. In this case, if by any chance somewhere in your app you call the video player component like enable, it means that if it's not started, that path of code is never going to be executed. Yeah. Question? Sure.
Just wonder if you have some comments about these lifecycle components and what the existing specific
With Kotlin?
Yeah.
I think it's easy. Like, I haven't written, like I wrote a little bit with Room, like the database stuff, but never did the lifecycle stuff. But I guess it shouldn't be different, because actually even the converter should do a really good job for that, because now that you have things inside the support fragment and the support activity, like in your regular Kotlin file, you have an activity in Kotlin, you just have to do get lifecycle and still call this method. So there is no problem. Unless you want to do like more specific stuff, you might run into problems. I know people that run into some problems, but I guess like was very related to the use case, that what they were doing. It's not really about like the general stuff that you can do with this library. Okay, so I think I forgot to mention that in the presentation, but LiveData is actually a lifecycle aware component. That's why it knows that if you're loading stuff and then its scope dies, it's never going to stop. It's never going to emit data to that specific location, because it knows that the lifecycle is no longer existent. So as I was saying, there are two different components. So you can pretty much use Room without using the lifecycle stuff. So actually, I started this presentation with an example where you would use Room as so you have this list to get movies for Room, which was a regular list. So you could use that without even using the lifecycles. Like,
I mean, for example, I have a problem if I put some kind of connect initiation rule with ViewModel, and it's work as a dark mode and doesn't work as really real time, just play with stuff and just work. And I just not investigate this
so you can.
Maybe we can talk about it.
Sure, it's fine.
Yeah,
There was one more question.
oh, I want to make sure we have enough time for
Sure.
Q&A, but are you sticking around? You can
Yeah,
answer questions.
I'll stay around, so
Yeah.
we should probably.
Let's take 5 minutes before we bring up the next speaker. Washrooms are that way, pizza is that way.
And thank you.
Thank you, Dario.